Good morning. Our first presenter is Dan Pardi. Dan does research with the departments of neurology and endocrinology at Leiden University and behavior science department at Stanford. He is also the CEO of Dan's Plan, which implements the loop model to sustain health behaviors to leverage wearable technologies and ancestral health methodologies to empower healthy living in the modern world. And he is the bomb at photo bombs. Please welcome my friend, Dan Pardi.
Thanks, Michelle. Thank you. All right, let me start my timer. Good morning, everyone. It's so nice to be kicking off Paleo Effects. I'd like to congratulate everybody who's been involved in putting this together. It's such an effort to make something like this happen, and it's really fun to see something like this grow over the last couple of years. And it's also interesting to think about where this will be in a few years from now. So, one disclosure is that I'm a co-creator of something called the Ideal Weight Program, which we sell on Dan's Plan, the health technology site that I started. And so I wanted to put that out there before I begin this presentation on weight regulation. So every conversation on weight regulation discusses energy balance. And what is energy balance? All right, this is this idea that energy intake and energy output are in balance, and it leads to something like this. And this is actually an unedited screenshot of my weight over the last 3 months. Okay, so I'm not consciously trying to regulate my weight up and down every day, but it happens autonomically, subconsciously, and it goes up, it goes down, but it stays around a set point. All right, this is what theoretically should be happening, but why are we seeing this? All right, why are we seeing this? Why have we seen a 260% increase in the prevalence of obesity in our society over the last 50 years? Now, to conceptualize the magnitude of this another way, if that same percentage increase happened from now till 50 years from now, 90% of the population would be obese. All right, just a different way to view it. I don't think that's going to happen, but there's a lot of theory about what's going on, right? And why is that? You know, if we nailed it the first time, then people wouldn't be offering a lot more theories. But the reason why there are so many different ideas about what's happening is because this is an extremely complex situation. This is an Obesity Systems Map, and this is looking at all the different possible influences that are affecting the defended level of body fat. Okay? It's very manifold, it's very complex. In fact, I just did a search to see how many publications, scientific publications, were in PubMed last year, 2013, almost 10,000. So as a researcher, it's becoming almost impossible to keep up with the amount of literature that's coming out on a yearly basis just on this topic, let alone all the topics that relate to it. So it's very, very complex. And yet, at the same time, there are some seeming signals that are elevating from all of the different data. And one thing that we see is that in obesity, there are 50 different comorbidities that have increased risk when you become obese. Okay? 50 different diseases and conditions that increase their risk when you're obese. And so is being obese a marker of a larger truth? And I believe that it is. So this is an opinion that I'm sharing, that weight gain is caused by this broken lifestyle, which is really an idea that permeates this community in a lot of ways. Right? That lifestyle that is in discordance with our biology that leads to not only obesity, but other conditions as well. All right? Now let's look in the same 60-year period where the obesity rates have skyrocketed. We've seen that there is a 40% decrease in the amount of jobs that require physical activity. Right? There's a 20% reduction in sleep time on average from self-reported sleep surveys. This is, by the way, equivalent to 1 night of sleep loss per week. And then we also see that we're taking in more calories. All right? We're taking in 360 more calories per day, right? So why? Why are we eating more? And to understand this, I want to talk about some of the components of our body that regulates body fat. And Body fat is mostly regulated. The main center for regulation is in the brain. And I'm going to talk about something called, at first, the metabolic brain. Now, the metabolic brain is a concept of components of the brain that are receiving signals either from food or from other parts of the body to then regulate food intake and also energy expenditure. Okay? So the first part of this is meal regulation or satiety. This is a component of this metabolic brain. So how does this work? Okay? This is where you eat food, all right? It is ingested, it is transported, digested, and substrates from the food get into the bloodstream. They travel up to a part of the brain called the brainstem, and there, both signals that are released from, so when you, by the way, when you eat the food, hormones are released, and those hormones get into the bloodstream, and they'll also trigger nerves within the gastrointestinal tract. And all of those signals from the blood and the nerve signals will coalesce in the brainstem. And from there, it eventually will lead to a feeling of satiety. So you eat, you're eating, and then you're feeling satisfied, you stop eating, and that lasts for a little while. You get hungry again, and that cycle, this episodic cycle, repeats itself. All right? But here's a really interesting concept around satiety that helps us understand part of the reason why we might be overeating. So satiety is only partially dependent on calorie intake. All right? There's not a perfect correlation between calories and satiety. All right? So some foods are more or less filling than others. So what are the factors that make a food more satiating or less satiating per calorie? So decreasing satiety, meaning that that you don't get as full per calorie, are things like, these are food properties, by the way, caloric density and fat. All right? Things that increase satiety are things like protein and fiber and water. Okay, so now I'm going to read a quote, and this is, I consider this mandatory reading for anybody who's interested in this subject. All right, this is actually, it's not published yet, so you're going to have to look for it. So now that I've whetted your appetite, you can't find it yet, but you will be able to. And this is from Dr. Stephan Guyenet. It's entitled The Sensory Properties of Food, Energy Intake, and Obesity, An Evolutionary Perspective. And it's going to be a book chapter in ancestral health. Non-industrial cultures did not generally have the technology to purify foods into a more concentrated state. Carbohydrate was typically obtained from food with a higher water and fiber content. Fat was not typically isolated, but occurred in conjunction with foods that contained a substantial quantity of fiber and or protein, and this promoted a less energy-dense, less refined diet. All right. Now, to conceptualize this concept, I'd like to talk about volumetrics. Now, this is a book that's been written by a professor of nutritional sciences, Barbara Rolls, at Penn State University, and this is a concept that explains what we're talking about, energy density, the factors that make you feel more full. So both of these have the same amount of calories in them, all right? On there, you've got 2 halves of a sausage, some processed, looks like mac and cheese. On this side, you've got some shrimp, some potatoes, some steak, right? This was a little bit more paleo. I know it doesn't perfectly fit into what is considered paleo among some certain circles. But think about what you would get more full eating. Which one? And another example is this. So this is a processed tart compared to the same amount of calories as 8 little jars of berries. Now I know for me, I could probably really easily finish this tart, but I probably couldn't finish more than 7 of these jars of berries very easily. So here's a key concept that I'm going to put out right away. Highly processed foods, right, which are energy dense, make you eat more calories before you're full. All right? So if we think about why are we eating 360 more calories than we used to 20 years ago, we are eating more processed food, and you don't feel as full per calorie. All right? So now let's talk about fat regulation. Now this is the second aspect of the metabolic brain. So first was meal regulation. Now it's fat regulation. All right? So the first thing I'd like to talk about is a study from 1943 from John Brobeck. Now, this was a definitive study because it was for the first time it showed that overeating is the primary cause of obesity. And in this study, he lesioned mice's ventral medial hypothalamus. This is a center in the brain that is very important for body fat regulation. So they basically took it out of the brain of these mice. And what they found is that they would overeat, and then they'd gain weight. And here are 5 key findings. So damage to the hypothalamus caused overeating. Food intake was sufficient to explain the observed weight gain. Overeating was necessary to obtain weight gain. Decreased activity was secondary to the food intake. And overeating subsided eventually. So they had overeat, and then once they reached a certain body weight, they would stop overeating. Okay? So it appeared that there was the lack of a satiation signal from the removal of this tonic long-acting signal caused overeating, which caused weight gain. All right? And this led to the lipostasis theory, that energy balance is controlled by a feedback loop. Okay? The amount of body fat that you keep on yourself is controlled by a feedback loop. All right? And although the amount of stored energy that is sensed by the hypothalamus, and then it regulates energy intake, both food consumption and energy expenditure, to maintain a constant body fat level. But they didn't know what the signal was. So they knew that this feedback loop was happening, but they hadn't identified the signal yet. And then in 1994, Robert Friedman from Rockefeller University discovered leptin. And this is a quote from him of the paper: "Leptin may function as a part of the signaling pathway from adipose tissue that acts to regulate the size of the fat depot." Okay? And since that time, before that, we thought that fat was just this inert substance that helped the body warm, provided energy substances for energy. But now we know that it is an exocrine gland. It releases hormones, right? So the adipocyte will undergo a normal signal transduction like other cells to produce hormones, right? And in fact, I think that the current count is close to 50 different substances that are metabolically active that are released from body fat. Leptin just being one of them. Most of them are inflammatory, all right? Now, inflammatory in some contexts, it sounds really bad, and it is when it's out of balance. But normally, it's just helping this inflammatory signaling is maintaining normal physiological processes, right? So things like blood pressure and energy regulation, lipid metabolism, right? So now let's look to see, how does leptin actually influence both food intake and energy expenditure in the brain, okay? So it's released from fat proportional to the amount of stored triglyceride. And then it's got to actually get into the brain to do its job, all right? So leptin will inhibit neurons called neuropeptide Y, or glutylated polypeptide. These are neurons that actually make you very hungry. So if you stimulate those neurons, they make animals feast ravenously, all right? And they'll also decrease energy expenditure, both of which will serve to increase the amount of stored body fat. Next, they will promote the activity of a neuron group that does something completely opposite. It suppresses appetite and it increases activity, okay? So how does it do this, right? By the presence of leptin will act through endocrine mechanisms, by releasing hormones, through autonomic mechanisms, and then also by changing our behavior. And interestingly, we also know that leptin will affect synaptic plasticity. So the presence of leptin will also keep other neurons healthy and functioning well when in balance. Okay, so now let's talk about how sometimes you have to talk about things very encapsulated to understand the concept. Let's talk about how they work together. So how does leptin influence satiety? So these numbers are just basically to conceptualize the point that I'm trying to make about how they work together. So here you've got a steady state situation, right? And so basically your leptin level is, we'll call it normal, right? And you take in a meal, right? And you develop a satiety signal of 2, okay? Now, if you've overeaten, your body fat stores increase, right? Leptin levels rise. The same exact size meal will create a different level of satiety. So you actually get full sooner. And the reason being is, if you remember the different satiety signals that I was talking about earlier, they coalesce in the brainstem by sampling blood and looking at nerve signals. Well, one of the things that they sample in the area postrema is actually the leptin level. So conversely, and here's the rub, when you lose body fat, the same size meal again produces less of a fullness signal, so you're encouraged to eat more. So this is one way where these two systems interact to affect, ultimately, this defended level, this what's called defended adiposity, okay? So then why would we gain fat, Right, now we need to talk about this concept of leptin resistance, or the insensitivity of this signal by the body in various places. And when we talk about leptin resistance, there's really multiple different places. It's not just happening in one place. It can happen all along this chain, from leptin synthesis to its release, to its transport in the blood, to getting into the brain, many, many things. And I'm just going to talk about a few. So before I talk about that, let's talk about obesity and inflammation, what leads to insulin resistance. So with weight gain, okay, you have an upregulation of your adipose tissue. Right? Now remember that adipose tissue, or the adipokines that are released from fat are inflammatory. All right? So when your fat depot increases, you enter into a more inflammatory state. This weird thing happens where macrophages, which are immune cells, will actually enter into the fat tissue, which causes more inflammation. This causes some of the adipose tissue to die, which causes more inflammation. And this all leads to this chronic low-level inflammatory condition will lead to altered signal transduction, which means that these chemicals that are being released by fat that are meant to serve as a signal to cells, that signal is breaking down. And that leads to both leptin resistance and insulin resistance. So, or a condition of metabolic dyshomeostasis. All right? We're talking about homeostasis or balance earlier, where that body fat level is regulated. Now we've basically seeded the environment, the internal environment, for balance, where balance is not there. Okay, so let's look at one place where leptin resistance occurs. So this is the blood-brain barrier. You have an amount of leptin that is circulating within the bloodstream, and it needs to get into the brain. And in 1996, the leptin transporter was discovered. So this is a large molecule. And in order to get into the blood, or to get into the brain, it needs to use this transport molecule to get in there to communicate its signal. All right? Well, what happens is when there's a high level of leptin circulating, then it can actually break the receptor. And it can also saturate the receptor. So there's only a certain amount that could get through, but then also too much will make the transport mechanism inefficient, ineffective. And very interestingly, I'm not going to talk about this today, fasting actually increases the capacity of the leptin transporter. So if you have this situation where the leptin transporter is broken and you fast for 24 hours, it restores function. Now let's talk about hypothalamic resistance. So we were talking about this a little bit earlier when in John Brobeck's rats, that area of the brain was lesioned. These rats started to overeat and they gained fat. Let's see what happens in this situation with leptin resistance. So this is a major pathway, problematic pathway. So when you have high level of circulating adipokines, it can cause inflammation within the central nervous system as well, and it initiates this inflammatory pathway, IKK beta and nuclear factor kappa beta. Okay? This can lead to altered signal transduction within those cells that are receiving the leptin signal in the hypothalamus that are controlling energy expenditure and food intake. Okay? And it also associates with damage, neuronal damage, right? So you see things like gliosis. By the way, glia cells like astrocytes or microglia, these are things that will provide nutrition to neurons. They will help with inflammatory regulation with neurons, which is the proper signaling. And so you see these markers of stress. There's damage that's taking place. ER stress, autophagy, which is usually, so you have increases in autophagy. Autophagy is a mechanism, an internal mechanism to clean out basically defunct proteins within a cell. So when that's upregulated, it means that there's more potentially defunct proteins. And you also see reduced neurogenesis, so more scarring you could think of, and then also less new cell formation. And what does this lead to? And here's the rub, that this overnutrition that breaks the system leads to hyperphagia, right? So this is almost an identical situation to John Brobeck's rats. They lesioned the ventral medial hypothalamus, right? And that caused them to overeat and gain weight. So now overnutrition creates this inflammatory state which breaks the hypothalamus and causes hyperphagia, causes you to want to overeat all the time. So, interesting. Now I want to mention something else, that this overnutrition-mediated inflammatory state also will lead to well, it leads to, again, this increased inflammation within the central nervous system, altered mitochondrial function. And it's not just obesity that occurs, but it's also progressive aging, Alzheimer's disease, Parkinson's disease, other neurological conditions. Okay? And remember earlier when I was talking about obesity maybe being a marker of a bigger problem, right? It is both stimulated, the problem is this overnutrition, all right? And somehow over that process, the system breaks and it makes you want to continue to overeat. So it's this positive feedback loop. All right. So now let's look at exercise and how it influences this system. So there is some popular trend that exercise is just not that important for weight loss. And it actually, the results have been disappointing in some ways, because it's true that exercise doesn't support weight loss very readily. All right. But it's doing some other very, very, very important things. Okay. So, okay. Exercise in, let's say I'm going to advance too much. Okay, exercise in lean people does not affect these appetite promoting or appetite suppressing neuron groups in the hypothalamus. It doesn't affect them directly. Okay. However, in obese, it does. It does affect them directly. All right. So in the obese, it actually, oh, by the way, and I'll go back. So all of this, it doesn't really affect food intake directly in a lean person. But in an obese person, it actually can suppress hyperphagia, this overeating that is stimulated by this broken brain. Okay? And how does it do it? Well, like fat cells that release hormones, adipokines, muscle tissue can release myokines. And we know that one prominent myokine that is released from exercising is something called interleukin-6. Now this, you see it both in the body and in the brain. Releasing of IL-6 will stimulate an anti-inflammatory factor, interleukin-10. All right? And this has the exact effect that you would want to see. It suppresses this central inflammatory pathway, it suppresses markers of damage, and it increases and it maintains signaling, proper signal transduction for both insulin and for leptin. Okay? So exercise, you could say, becomes even more critical once you are obese. All right. And this is a quote from this article. Physical activity could help to reorganize the set point of nutritional balance and therefore aid in counteracting the energy imbalance induced by overnutrition through the anti-inflammatory response in hypothalamic neurons. Okay? So, now I'm going to switch gears, check my time. 1 second. And I'm going to talk, doing good. I'm going to be talking about, I was concerned. I'm going to be talking about the cognitive emotional brain and its contributions to feeding. So we talked about the metabolic brain, and now there's the cognitive emotional brain. All right? And this can regulate energy intake and expenditure as well. So let's first talk about, whenever you're talking about cognition, you need to be talking about the frontal cortex. All right? This is a key part in higher level cognitive thinking and involves something called, it actually supports executive functioning. Now, executive functioning is a task directed at oneself to influence a future outcome. All right? So this is to do with goal planning. And so if you think about a goal, right? I want to eat well, or I want to lose weight. You have to conceive the goal in your mind, right? You have to plan a strategy on how to get there. You have to interpret information as it comes up and then re-strategize to try to, make sure that you're getting to that goal, right? And all of this is very complex, right? So these sorts of functions provide activation for starting work, for focusing on a task and not being distracted, for sustaining your effort at something. All of these things are necessary, right? And now let's look at a couple of different components of this cognitive system. And the first one I'm going to talk about happens in the dorsolateral prefrontal cortex. And these terms, the anatomical terms, are usually very long, but they're also just very locationally descriptive. Like, this is where this is happening, okay? So this is the area of the brain that if you look at its activity while somebody is thinking and being imaged with a functional magnetic resonance imaging scanner, you can see this part of the brain light up. All right? This is the part of the brain that is involved in self-control and delayed gratification. Okay? Now, we have another part of the brain, the ventral medial prefrontal cortex, and this part of the frontal cortex responds to palatable food, right? And the response will diminish in feeding palatable foods to satiety, right? So we might have identified another satiety center here. And it also will stimulate feeding if you stimulate dopaminergic neurons, dopamine-emitting neurons in this part of the brain, all right? It'll stimulate feeding. So this is a really interesting, let's look to see how these two centers will interact. Let's look at how these centers interact when you're deciding on food. This is a really interesting study that was done at Caltech. And what they did is they had people come into the lab, they had them put on goggles, and they had them look at 180 different food options. And when they did that, they were in a magnet or fMRI, and they were able to look at the brain, how it was working, and then they were also to see what kind of choices they made. Now, an interesting part about this study is they told everybody that everything that they said yes to, out of that group, one would be randomly selected, and they would actually get that to eat. Okay? And by the way, that sort of thing is really important when you're doing sorts of studies like this because it changes what you actually, there's like what you would decide to do if you're kind of being watched, and then there's what you decide to do when you're like, oh, actually, I might get this, right? It's very different. So they had people look at different foods, right? And then afterwards, they would have them rate them as either healthy or unhealthy, or tasty or untasty, okay? And what they found, oh, I'm sorry, I missed an important part. Every 10 food items, they would tell the person to think about the tastiness of the food, or think about the healthfulness of the food, or think normally, think naturally, don't think about anything particular, just look at the food and decide if you want to eat it, okay? So how did this affect what they decided to eat? Well, very interestingly, thinking about taste was no different than thinking normally. It shows you what we usually focus on, right? And there was no difference, excuse me, there was no difference in the choices between these two different conditions. There was no difference in brain activation, right? And there was very little activity of the self-control region of the brain. Now, when people were told to focus on the healthfulness of the food, they were less likely to eat unhealthy food. They basically said no to more options. And this area of the brain that responds to palatable foods was getting more active input from the self-control area, all right? So activating self-control areas helps the brain consider the health benefits as well as taste as it's assigning value to a particular food, all right? So now I'm going to talk about another component. So we've talked about the self-control area, an area that responds to palatable foods. I'm now going to talk about another really critical area of the frontal cortex and food intake, something called the orbital frontal cortex, another part of the frontal cortex. Okay? So as you eat food, right, it's a sensory experience. Smells, tastes, even the environment that you're in, what you're hearing, what you're feeling. Well, all of these experiences, these sensory experiences, will coalesce into this part of the brain where it undergoes something called multimodal sensory integration. So all the senses meet here, and you get this one overall experience from the food, right? And, oh, sorry, one slide behind. And the orbital frontal cortex is a key part of your reward system. And I'm not going to go into all the details here, but these are the components of the reward system proper, the nucleus accumbens, ventral pallidum, ventral tegmental area. These are things that are orchestrating, they give you the sense of pleasure from something, and they also help you with motivationally with what you want, right? Wanting something, so the motivation for goal attainment, right? To attain pleasure in the future. Those two systems have to work together. So reward is actually a very complex topic. It's not just pleasure, which is how we tend to think of it, but you have to parse it into three different categories. Pleasure, learning, you've got to remember that experience, and then motivation, okay? So, after all this, you have a reward value that is designated, and this reward value is then remembered. right? And this memory of a experience with food can then serve to influence what you eat in the future. Okay, it can influence. You get hungry, and you're like, oh, what do I want to eat? And what's most salient, what's most present, what comes to mind are these powerful food memories that are created by pleasurable experiences. Okay, and that's what the orbital frontal cortex will help do. It'll help to influence reward memory and motivation for attainment when you're hungry. It helps direct your focus for what you should eat when you're hungry. Now let's talk about overeating. Okay, I'm going to read another quote from Dr. Guillenet's chapter. Industrial diets are characterized by advanced food technology that permits a high level of variety and exquisite degree of control over food sensory properties into a diet that mirrors the sensory preferences of the human central nervous system. So what technology has been able to do, whether we've understood it or not, is create new food products that match what we respond really heavily to. Okay? I wonder if you can think of any examples of that. So, and we know that this sensory-mediated food intake, by the way, in taking this picture, I did have to finish this because I couldn't throw it away. So we know that these are factors that will lead, these are things that will promote overeating, right? One of them is palatability, which is this how much you like a food. There's also other sensory-mediated food intake drivers like variety. So there's something called sensory-specific satiety, which is this idea that the palate is renewed when new food items are brought in front of you. It's like, oh, I'm full, and then all of a sudden either dessert or something else comes in front of you and you have an appetite again, all right? And it's not, and this is, basically, you're listening not to the metabolic aspects of what's happening from the food that you've eaten, but you're listening more to the sensory experience that's driving. It's a whole different aspect that's driving food intake. And in fact, these factors are really potent at making you eat more food. So this is basically from a variety of different research, but you see the magnitude of overeating that can take place at a meal. Someone could take in 50% more, up to 75% more, even higher at a given meal. So you'll eat this many more calories, right? When you are basically eating based off of sensory-mediated food intake, all right? So earlier we talked about how highly processed foods make you eat more calories before you're full. That's not even fair. You're trying not to overeat, but you've taken in more calories before you can even realize it. Well, together, highly processed, highly palatable foods make you eat more calories before you're full and more calories after you're full. Okay? This makes it incredibly easy to overeat. All right? Now, just like with the metabolic brain, with the sensory-mediated areas, overeating begets overeating. And this is work from Eric Steese in Oregon. And what he found is when people eat a lot of, they have conditioned hypereating where they're overeating regularly, you see a downregulation or a blunting of pleasure in the brain. And you see an upregulation or increased craving. Now, this is the exact type of situation that you see in a drug addict. It's a condition that's described as low liking, high wanting. So there's low pleasure but high craving, okay? And this happens in response to overeating. But why are we overeating in the first place? So what is the initial overeating risk? And what we see is that he looked at different types of people. People that have an elevated responsivity in their reward areas tend to be the ones that overeat first before there's a problem, right? Are there any other factors, however, that increase our responsivity, our rewards responsivity? Yes, and this transitions into the lifestyle section, so lifestyle and cognition. All right. So I'm a sleep researcher, and I look at how chronic sleep disruption will influence decision-making around food. So this is an area that I'm very interested in. And what surprising, there's been a lot of research on sleep in the last 10 years. We've been looking at, well, what's going on? You see alterations in metabolic hormones, you see alterations in glucose levels, how that's regulated. But one thing that's really kind of coming to the surface has now been repeated multiple times across multiple different groups, St. Ange, Christine Benedict, Matt Walker out of Berkeley. You're seeing that when somebody doesn't get enough sleep, when they're sleep deprived, these hedonic areas of the brain that respond to palatable foods, that respond to that peanut butter cup, are overactive. They're overactive. You don't get enough sleep, and these centers become overactive. Remember, we're all getting 20% less sleep than we were as a society 50 years ago, right? And this can also lead to defection. And this is some of my research. I'm just dropping this in here. What this means is that, and what I did in my research is I sleep-deprived subjects, and I had them make food choices, and then I had them rate the food. And what I found is that when they were sleep-deprived, people were more likely to eat food that they rated as less healthy. They know it's unhealthy, but they're more likely to eat it. So not only do you have increased hedonic drive, pleasure drive, you're more sensitive to these areas, but you also have decreased self-control. The ability for top-down inhibition of these reward centers is functionally offline, okay? So now it creates a very impulsive situation. So what else affects inhibitory control? Exercise. When you regularly exercise, it increases the strength of the neurons within the prefrontal cortex, the self-control area. Okay? This improves your executive functioning skills, so you have better ability to inhibit an impulse, right? You're better at task switching, you have better focus. And when you look at this relative to eating, you see decreased disinhibited eating. And disinhibited eating would be basically passing by a candy bowl and saying yes, even though you ordinarily wouldn't want to. It's not a part of the way that you're trying to live, all right? And it also showed that people have an increased preference for lower fat foods. Just like the study at Caltech, people chose foods and rated them higher when they were consciously aware of health, when they were thinking health, all right? So, why do we get fat? And I'm going to pull all this together. We get fat because of overeating, this caloric surplus, all right? And the reason that this happens is because our modern food environment has a lot of highly processed foods, many food cues, which I didn't go into, and also a lot of highly palatable foods. And this creates a situation where you have decreased satiety per calorie from what you're eating. You're more likely to eat it because it's going to offer less fullness per calorie. And then on the other hand, it's also going to stimulate basically sensory-mediated food intake, so you're more likely to eat past satiety. You recognize that you're full, but you still want to continue to eat. Now, how about unhealthy lifestyle? So that's the modern food environment. Unhealthy lifestyle with insufficient activity, you have worse appetite regulation, control through self-control, and you also have less of a calorie margin, so it's just easier to overeat. Secondly, insufficient sleep makes you more impulsive and increases hedonic drive. And by the way, insufficient sleep makes you less likely to be physically active, and physical inactivity has been shown to make you sleep, is shown to contribute to inadequate sleep, right? So it's basically two sides of the same coin. So now, an unhealthy lifestyle in the presence of the modern food environment, if you think of, there's something called moderator and mediator analysis. Mediators are explaining the effect, and a moderator strengthens or weakens it. So the modern food environment is really mediating this effect by the type of food that we're eating, but an unhealthy lifestyle makes us more likely to eat those foods that we recognize as less healthy. And not only that, this modern food environment also will have an effect on this thermostat in the brain, the metabolic brain, that's looking at just the internal chemical signals to try to regulate energy intake and energy expenditure. So does an unhealthy lifestyle, and as you gain fat, as we discussed, this can break this part, the ventral medial hypothalamus, it can break that, and it can create hyperphagia or chronic overeating. So thank you very much. Actually, I'll mention one other thing. There are, of course, other influences. As I mentioned earlier, there's a huge amount of influences, but none of those make this any less true. I think by focusing on, instead of trying to take in all of the data at once, this is something that you can operationalize into a plan, into a lifestyle, and into approach that can help you with your weight control goals. So we're releasing a ebook today, and why do we overeat and how? Why do we gain fat and how do we lose it? You can go danceplan.com/ebook and you can download it. It's free. It talks about some of the concepts that are in here now, and also some approaches about how to take this information, construct a positive lifestyle. And by the way, it really applies, a lot of this information applies to everybody in this room, whether you have ambition for specific weight control goals or not. We're really trying to promote a healthy lifestyle, sufficient physical activity, sufficient sleep, and really what we consider a healthy diet, which is more in line with our ancestral diet, which is less energy dense, less processed foods, very much similar to a paleo diet, which paleo diet does a lot of people well, and there's some legitimate criticisms, but the diet that we're suggesting is very much in line with the paleo diet as well. So thank you so much. I think we have a few minutes for questions. I'm happy to take them if anybody has them. Thanks. Yeah, Chris. No worries. So genetic predisposition, there are monogenic traits, which is where a single gene is broken, and maybe it's an area that is integral in controlling energy regulation. And these are actually pretty rare. A lot of obesity is thought to be more polygenic. So people that have certain genetic traits have a greater predisposition for fat gain. So they, in an identical environment, they're more likely to respond in a way that makes them overfat to the same sort of lifestyle and diet. Okay. Now, in Eric Sties's work, he showed that people that had, this is one I mentioned earlier about the blunted reward system and the activated wanting system. He looked at children that had a high risk for gaining weight. And the reason why he said that there was a high risk is because he looked at the parents and what their BMI was. And what he found is that some of that population had this increased responsivity to these palatable foods, right? So there are some people that are predisposed to it, which really I think just makes me think those sorts of people more than anything else need that healthy lifestyle, right? There are what I think is that people that have less disfavorable predisposition, they can tolerate a little bit more before the problem happens. So that's how I would, and there's many different areas that you can go to into genetic predisposition. It can affect every single part of the system that is influencing the defended level of fat. But I'll stop there and take any other questions. Yeah.
Do we know at what point exercise can counteract lack of sleep? I work with new moms who are trying to get back on track, and they're not going to get the sleep.
Yeah.
And exercise can sometimes put them into a stress situation, metabolically.
Yeah.
In addition to the lack of sleep, and so.
Yeah, it's a great question. So, physical activity and exercise are different. I usually try to think of physical activity, and some of the studies that I showed on impact in the self-control areas of the brain were benefited by 6 months of walking versus versus what they had as a control was somebody who was doing stretching, right? That had a very significant impact on their ability for for regulation. So to go back to what type of exercise can we be doing and how to get sleep, as being a new dad, I can say that this has been challenged a little bit. A really good tip is to spend more time in bed. If you need 8 hours of sleep, or you think that that's how much you need, and you spend 8 hours in bed, you're not going to get 8 hours of sleep, right? So if you can spend an extra hour in bed, right, then you're more like, it might be fragmented as you're getting out to tend to the baby, but then you're likely going to have a little bit extra time to wear off that sleep pressure. What I would say is that a large part of our society is telling you not to listen to your body, to work hard, push past, right? I have another presentation where I show a bunch of advertisements that's basically talking about what I'm referring to, and it's all like, work out till you puke, right? Well, I think that it's really smart to listen to your body, really smart. And if you're not, in your own mind, if you don't think that, for exercise to be meaningful, it has to be 100% all the time. That's a really good, I think, mental framework, right? So rather, there's a huge spectrum of activity. If you're not really feeling, energized, you can go for a walk, you can do some stretching. There's a spectrum. And if you're feeling good and your body's telling you to, do something more aggressive, then you can do that. And you can so there's the Department of Health and Human Services has weekly exercise recommendations, and what they show, and this is basically a task force of academics that look at the research and then try to say, how much exercise do you need in order to be healthy? What's the level, not the type, the level. And they do a little bit about what type you should get. And what they found is that you want to get about 150 to 300 minutes of moderate activity per week, but that there is some efficiency if you work out more intensely. Right? So you can cut that time in about half, and if it's really high intensity, you might be able to cut that time in half again. And so with that research, I think has promoted this culture of more high intensity training, which is not bad, but it's also, in some ways, you can think of it as a part of a culture that's systematically trying to reduce physical activity in our life. Right? How do I get this over with as fast as possible?
If I'm not doing it intensely enough,
Yeah, totally. And that's not right. And so you've got, you can walk, but going for a couple-hour walk is not like doing a couple-hour CrossFit WOD, right? So think of that. What feels right to me today? Have a variety of things that you can select from, and then choose the one that works. Yeah.
So I unfortunately came in late because of the registration thing. I missed the part where you were talking about sleep, and that's getting 20% less than before.
Yeah.
I'm wondering, in your experience working with people, what range of sleep? I mean, is there really a range of sleep that people need, or does it just? Am I only tired because I'm not getting, what I really need?
Yeah, so the amount of sleep somebody needs changes across the lifespan. There's individual differences about how much sleep that you need. The general range is somewhere between 7 and 9 hours, okay? And there are outliers to that. Now, if you need 9 and someone says get 8, then you're getting less than you need. If you need 7 and someone says get 8, which is, by the way, the average, so you can't apply population averages prescriptively, but it's a good starting place, all right? And so your question was how do you know how much you're getting?
How can you know how much sleep you actually need?
Yeah, there's a little bit of trial and error and testing to see how you feel. So the things that matter for sleep are timing, intensity, and duration. All right. So duration is how long you slept within a 24-hour period. Timing is when that sleep is actually occurring. So if you sleep 8 hours from midnight to 8, but then the next night you sleep 8 hours again, but it shifted 4 hours, it won't be as restorative as the night before, if that midnight to 8 is your regular time. Okay? And then intensity has a lot to do with more of the architecture, the concatenation of different sleep stages. Sleep is a very active process. Okay? What affects that are things like light exposure during the day, physical activity, right? So it's living, again, this, the way that I think about it is this metabolic homeostasis, this internal environment is inseparable from this relationship with our external world, right? Our lifestyle, our internal genes evolved with this lifestyle, with this relationship with our world. Light, sun, dark, food, exercise. And so just trying to pinpoint one thing, it's like, we gain weight because of fat, we gain weight because of carbs, we gain weight, whatever it is. It's really facile to think of it that simplistically. And it's actually missing a great opportunity to help somebody with the big issue, which is, okay, here's a lifestyle that we all need. Now let's use this goal, this idea, this motivation to try to maintain real, health in all of these different lifestyle disciplines. Yeah.
So you seem to be focusing on avoiding the energy-dense processed foods, but
Yeah.
you also disagree with sort of the paleo trope of eat fat to lose fat because that is the natural and so energy-dense.
Oh, 1 sec.
Yeah, I was just asking, since you focus on avoiding energy-dense processed foods, you also disagree with the eat fat to gain fat, even if it comes from, paleo grass-fed animals, because it is so energy-dense.
Yeah, so there's a really good, thank you for that question. And if you couldn't hear it, essentially the question was, so, since we talked about how energy density influences overeating, how do I feel about these aspects of the paleo culture, which talk about, eat fat to lose fat, et cetera. So if you noticed, one thing that I added in about satiety is added fats versus fats within foods. And if you remember that quote, that fat that's contained naturally within foods is really, I think, fine. And people can thrive on a higher fat or a lower fat diet. But I think that when you add additional fats, those additional added fats are not always accounted for in terms of fullness. So if you add 300 more calories to the meal, you might not necessarily feel 300 calories more full. So it can, and this is why some people can do very, very well with paleo, and some people can actually gain weight or not lose weight when they'd like to. So it kind of depends on what your eating style is, what you respond to. I do think that you can do well with a higher fat diet, but that is a very complex discussion. It could be a real presentation, a whole presentation. So I'll probably stop there, actually. But we can talk more afterwards if you'd like. Yeah. Okay. All right, game over. Thanks so much.
Thank you,
Yeah.
Dan Pardi.